Hi guys, and welcome back to Aid's Workshop. Right, this is going to be a bit of a bits and bobs episode. That's the one. Right, okay. Yeah, I got a meter or a couple of meters of this copper bar. It's 25mm by 6mm. I've cut off a piece 200mm long, and there are some holes I got to put in here at regular 50mm intervals. There's clearance holes for M10 bolts and clearance holes for M12 bolts. Basically it's a single point grounding point, shall we call it, or earthing point for a large generator. Yeah, it just makes it more convenient, but when an installer wires it up, if he's got a single point to connect all his earths up, it's a bit of a safety thing. So yeah, we had a batch of machines with a different setup, and this is much preferred. The new machines that are coming in now have this setup already on them, so we're retrofitting this system. So that's that. Right, okay, I did a little project with a drive brake mechanism a few months back. I'll put a link in the description to which video that was in. But I'm finally getting round to trying it out. A bit of prototyping work it was, a bit of R&D. So yeah, this lever engages a drive belt between a motor and a drive pulley. There's a rose joint on the bottom end here, and I've basically got to drill a new hole a bit further up where I've marked it there with a little bit of Sharpie. Just changing the fulcrum points a little on that. Part and parcel of the same project. I got this little brass spacer ring, and he just thinned that down by a couple of mil. That's simple lathe work. And final job, I got a load of these, they're cylinder heads off little silent compressors. We've had a little bit of an issue with some fittings that were a bit fragile, and we've sorted that issue out now, but we're left with a load of these heads that, other than having a snapped off fitting in the hole, as you can see, it's a BSP thread in there, snapped off fitting in the hole. So if I can get that snapped off fitting out of the hole, these heads are brand new. So yeah, we're going to do all these little bits and bobs and show you the process as we go along. Right, so we've got a little parallel device here. It's not critical, this. The only thing that's critical really is the distance between the centres, and that's not particularly critical. Right, so I need a 10mm in there. I think that's the 12. I got a 12mm drill I'll be using. Yep, that's the right collet for that one. Need a 10mm collet, which is there. Okay. So I'm just going to start off with a 10mm spotting drill. Come on. Yep. Oh, put that up in the collet with a 10mm spotting drill. Just nip that. Let's turn on some of my power here. Haven't been in the shed for a couple of weeks, so I think it was 2 weekends ago. So yeah, apologies guys, I haven't had many videos lately. Not to worry, we're here now. So what we got? Everything on. Let's just bring that down. There we go. Right, so first hole in the centre this way, and 25mm in from the end. Yeah, basically I can just start that cutter up. I'm going to eyeball it this way. As I said, it's not critical. That's good. Lock off wide. And first hole, 25mm in. So I'll eyeball the point of the drill. That's it. I'll set a 0 on my DRO. All zeros. Okay, so that looks a little fast. So spot 4 holes now. The first one there on the 25mm mark. 50mm long. And then in the Imperial. Okay. Right, that's better. There's a second hole at 50. $100. and then 150. Getting a bit of flex on the end there. I've done several of these now. Basically I'll just support it with the end of my spanner. So yeah, I've done loads of these and that's the method that works a treat. Okay, so that's spotted. Swap that spotting drill over for a 10mm drill now. I'll have to go up a bit. So I'm just sending the head up in power feed. There we go. Back down again. Ooh. Down you come. Yeah, same procedure. I'll just add a little bit of support there. 4 10mm holes. That's one. I could have put a couple of 1, 2, 3 blocks under either end of the part when I put it in, I suppose. But yeah, I mean, this works. So that's basically accurately moved across 50mm. There's 2 existing holes in the machine for the 10mm bolts to go through, so they need to be lining up. That's 50. That's the 3rd hole. Back across to my 0 mark, which is over there. Bit of support again. Okay, so 12mm drill now. Whoop. Come on, look at that. Nasty, stringy, horrible copper swarf. Oh, up again. Got to change the collet anyway. In with a 12mm collet. Oops. Up a bit more. Oops. Can't hold on to it. Okay. It's not that one, it's the 2nd hole. There's a 12. So that's at 50. And then the last hole. Okay, bit of support. I think that drill wants to sharpen. So that's the 4 holes in place. Now all I need is a nice chamfer on both sides of those holes. So let's pull that one out. I think my chamfering bit, which is where that's here, that's on a 10mm. So back up with a 10mm collet. Chamfering bit needs to come down quite a way. Here it comes into view. That'll do. And back across, indexing 50mm time again. Just whack the chamfers in. I'll probably freehand the ones on the other side. Oh, missed that one. Not quite deep enough. That's better. And the last one. There. Okay. So let's bring the drill back over above the chuck. That'll do. Drop it out the vise. Hold on to the part. You chamfer those four. So that's pretty much it. Simple little job. Two 12mm holes, two 10mm holes. I think in total I've had about 40 of these to do. I've probably got about 10 left, I believe. So the other little job, put a new hole in this arm. I've basically marked out approximately where it needs to go. So let's just bring that head down a little. That's where it needs to go. Spot it first. A little bit faster, I think. It's a little too fast. Okay, so that's it spotted. Let's send that head up a bit. This power feed on the Z axis, you can hear it rotating now. It just takes all the hard work out of it with this mill. It's obviously there's no knee on this mill that winds up and down. You've got the complete head winds up and down on a column. And to get to it, you're going to lean over the mill. I'll see if I can get you a picture of this. Yeah, so basically to wind the head up and down, I've got to lean over here to wind the handle. But I've got my switch here, vary speed. I can go up and down, and it just saves all that winding malarkey. So bring it down. That'll do. Switch it off and drill a hole. That's it. That's the hole I needed. Again, I think, shall I put a chamfer on there? Tell you what I'll do. I'll set X and Y to 0. Bring the part out of the way and just check. Let me bring you down. Yeah, I think I'll just check that that is an 8mm hole. I totally guessed. I just looked at it and thought 8mm, but yeah, it is 8mm. Okay. No problem, and I think I'll just deburr that with a Noga. It's easier. Okay, so that's that job done. New hole in the right place. So a little quick and dirty setup for this. It fits in my vise against the back face of the head perfectly, no problem, and it's down against the bottom of the vise. I got a 1, 2, 3 block against this head, which this side here, which has a shear angle on it, or a draft angle on it, so that I can swap heads over and push them up against the block, so I've got a reference point. The hole itself is 7.3mm through the bore there, and I've just got a 7.3 drill and just lined it up so it just slips down through the centre, so I've got a reference. Lock X and Y, and we're going to drill out the remnants of the previous part. So I'm on the second one of these. Slight change of plan. I'm going straight in with a 12mm milling cutter. Running nice and gently. Just removing the core of the, there it goes. Nearly screwed it out. Okay, that's got rid of that. And basically, simple little job now. I can see the threads all the way through. Take the cutter out. Oops, nearly dropped the cutter. I'm just going to pop the tack follower in here. Oop. That's the tack follower in. Might just have to send the head up a bit. Okay, put the tap in the hole, bit of pressure, spanner on the tap, it binds the original thread. Let's just bring that follower down a bit. I'm going to have to get a bit of lubrication in that follower, it sticks now and again. Okay. It's a cast alloy, so it's horrible stuff. It's a straight thread in the head and a tapered thread on the fitting. It's put in with a bit of liquid PTFE. These ones were actually Loctited in for some reason, but a bit of liquid PTFE, and it basically seals because it's a tapered thread on the PTFE. So that's another one done. So as you can see, it's milling cutter, bore it out, or machine it out, and then straight in with the tap, pick up the original threads. Let's get the part out. As you can see there, yeah, I mean, it's back usable again. It's going to go through a parts washer, get cleaned up, make sure there's no muck and dirt on it, and then it's a way to go. As you can probably see, guys, I'm being invaded. There's a lot of well, amongst all my sort of organised chaos, yes, we've got a little bit of floral activity going on in the workshop here. I think it's about 3-4 weeks since I cleared it out last. I think it's time to do it again. While we're on the subject, if I just bring you around, I have fitted my extension lead, or multi-extension lead, up on the wall there, out of the way of the swarf. There's a little mini lathe there hiding back in the corner. Yeah, that's going to be worked on one of these fine days. And the noisy power feed down there that gripes on most people when you hear it running when I'm trying to talk and when I'm trying to turn on the lathe. All that lot's going to be coming out and replaced, including its control box on the wall there. You can see my little vise which I use for filming on the lathe, and that's extension lead behind there. Is pretty much all the lathe plugs and sockets are plugged into there. So as it stands now, my socket on the wall here. The black one there runs the new one with the 8 sockets on it, not that I'll ever use that many, and the white one pretty much runs the lathe. So I've got to make this part. Excuse the background noise, it's very windy today. It's made out of aluminium. It's about clean up material. It's going to be about 18 mil thick, 90 mil long overall, 15 mil hole here, 25 mil, so 12.5 mil radius all the way around the outside, 20 mil thickness here, so that's 10 mil radius all the way around the end. In the middle of that rad, middle of the part, 10 mil in, is a 8 mil hole, 8 mil reamed. This hole is going to be 15 mil diameter, nominal. I'm going to be making a pin to suit at a later date. And obviously that's in the middle of this larger rad. So I've got an offset one side. That's the outer shape. 8 mil radius here, so that dictates the, in fact 4 mil radius, I got it wrong, that's a 4 mil rad. Got the drawing wrong. It's an 8 mil cutter anyway. So that's easy, it just dictates the diameter of cutter I use when I profile the outside. Probably going to be a rotary table job. And then plan view, looking down in, you'll see this dotted line here. 25 mil back in the centre line. There is a cutout through the centre, and it's going to be clearance on an 8 mil, so 8.1, you know, something like that. 8 plus I've just written. So yeah, a little bit of fun and a bit of setting out and working out in this one to get these outside edges all to blend in nicely, but I'm sure we can do something there. So the first thing I'm going to do, second sheet, I'm going to set myself out, rough this block out, put the 2 holes in. That gives me my datums for centres of the radius, or radii, the one on that end and the one on that end. So I'm going to leave it a little bit over length, 91, so that the radius can cut around the top when I do the rad. Centres of the hole, I'm going to come in 0.5 mil on this end from the blank, and 12.5 down. I'm going to use this top face as a datum, so that can be finished machined, and I'm going to leave it 1 mil over on this dimension, so 26 here and probably 20.5 here, something like that. So I need to rough out this part and put the 2 holes in. So aluminium, I like to put like to cut that across with a fly cutter. Let's just get a touch off. So I'll just clean up this space. There we go. So let's see how that does. So thankfully there's only one of these to make. Otherwise I'd probably set them up if I had multiples. Set it up differently. Cut's a bit harsh. I'll probably run back the other way with a couple of thou. Yeah, let's just run back the other way with a light cut, speed the cutter up a bit. Okay. Come on. There we go. So this part, yeah, I mean it was a sketch for a future thing. I'm not going to reveal what it's for at the moment, but just a sketch, and I've stuck some dimensions on an idea I've got. It's a tool for the mill. I'm not going to reveal it at this point, because I haven't designed it yet. But I've got a few ideas. and I do like to start with one part and make all the other bits to suit. This is my, there's no CAD here, it's sketches as you saw in the little notebook there. So I did a few sketches of the idea that I had, and then thought, right, let's start with one component, make that, and then that'll dictate the sizes of everything else. I probably could have put a bit of WD on there, but you get the general idea. So flick it over to the other side. I think this started at around 27-ish mil. It's not critical here because I'm going for half a mil oversized. It wouldn't matter as long as it's oversized on the 25. So we're going to look at 26 mil. Let's just see where I am roughly. 26.45. Back the other way, I don't want to be here. I could cut it the opposite direction, but I'll be throwing swarf all over me. I'd rather throw it at the back of the bench. Set a 0 on the quill. So I'll probably take 0.4. Tell you what, I'll take 0.35. So I'm taking 0.35 off. We'll have another measure. It should leave 0.1 approximately. So let's have a quick measure. 26.1. Oh, let's have a little bit of WD this time. Back the other way. Oh, put the cut on. And away to go. As you can see here, throwing swarf towards me now, but it's only a 0.1 cut, so they're not hot and nasty ones. But I have got my glasses on, and you see where they're going to flick and stand out the way. So the step along here, down to the 20.5, has got to be measured from this end. That's my sort of basic datum end. So I'm going to need to machine this end first. So bring down my Z-axis, I'll machine across this space, call it a 0, and I know how far back I gotta go. So let's speed that up a bit. There we go. I'll do the rest with the quill. Have I got enough cutter to do that? Just. Okay, so what are we running at? About 900. Let's just do a touch off here. Okay, set a couple of zeros on my DRO. Let's take let's say half a mil, shall we? Another 0.1. Lock X, do a climb pass. Okay, I'm going to set X as 0 on my DRO. Come back up with my quill. Okay, so I've got a 0 reference now. So I think what I'll do is unlock my quill, come down to a touch off. This is going to be approximately 5mm deep. We'll call that a touch off. Set a 0 on my quill. My distance along here, I think I'll do the back shoulder first, put a slot into depth, or a slot in first as a reference point. So that's going to be 61mm. I'll come to 60, come down a mil, and do a little slot through there. Let's have another mil. And another one. I'm going to go 4 deep just as a starting point. Okay. And we need to machine the rest of this away, so I'll just unlock my X a minute, see what my feed's doing. That's a good speed. Let's plunge into about there somewhere. Let the table run across, we'll remove that material. Just have a bit of WD. That's 4mm deep, probably 10mm width to cut, and I'm doing 900 with a cutter. Could probably go a bit faster than that. Yeah, it's just over 1000 RPM. Wind across the other side, back the other way. So I'm just going down another ½ mil now. I'll rough this out. Get up somewhere near my shoulder, I'm not worried where. I'll clean that up as a finish. Right, let's just wind across to 61 on my DRO. In fact, I think I'll do 60.5. Let's lock X. Rough that out. Okay. And I'll go to 60.9. There. I've got 0.1 left on the depth, 0.1 left on the shoulder. So I'll bring that depth down on the quill, that's there, wind across to my 61, that's there, finishing pass across here. That's it, just come off that base a bit. Undo X. And clean the final 0.1 off the deck of this. Off the end, go to the middle, back across. Back into the previously machined part here, back across, back the other way. Okay, so let me bring the quill up, come to the other end. And I want an overall length here of 91, so I'm going to machine this end now to bring it to 91. So I believe it was like 95 mil to start with, so there's going to be about 4 mil to come off here, I believe. Just going across in power feed, so I'll take a mil off it and then we'll have a measure. Come on, out you come. There, somewhere. Let's bring the head down. Oh. Do the rest with a quill. So about there, just underneath. Let's touch. Okay. Set X to 0, we finish with that. Let's take a millimetre off it. Bit keen, half a mil. Oop, that's better. That was me hitting the collet spanner. Take it to that mil again. Let's go just over a mil. Reset to 0. We'll take a measurement. Let's just stop that cutter. So we're looking for 91, 93.04. We'll call it 2 mil to come off. I'll do 4 half mil cuts. Doesn't take long. That's a half. 1 mil. 1.5. I think we'll go 1.9 and then a final 0.1. Okay, a final 0.1 mil cut. And we'll run that back the other way nice and gently. Okay, turn that off. Let's just check we hit where we wanted to hit. .02. I think we'll live with that. So I need to pick up on this edge with a wobbler. This edge being the datum edge, the 0. So let's just wait for the kick. Come on, come on. There you go. Not too happy with that one. I think I went a bit beyond. Do again. So the tip of this wobble is 100th out. There we go. I'm going to set a 0 in Y. I'm in Imperial, which is great. So I'm going to move over 50th out. I said 50th out, not 250. I'm not lucky. Re-0 Y. Okay. So that's the tip of the point over the top of there. Let's find the end. Come on. There. 0x. Move over 50 south. Which is... that's 49.9. Come on. There. X0, Y0, and let's go into metric. Okay, so I've just Y0'd and I'm not on Y0. Yeah, sometimes when you yabber into a camera. So I'm on X0 but not Y0 because I just lost it. There. Okay, Y0, move over 50, yeah, plonker, go into inches, move over 50 thou, Re-0 Y, change back to inches. Okay, so if I now go to 0, 0, in millimeters, that should place. Let's just do a quick sanity check because I've been messing about. Come on, you. Ah. This is why you don't use your fingers. I should be over that corner. Bring it a bit closer, and it certainly looks correct, right? Just making sure I haven't done anything wrong. So I'm 0, 0 on a theoretical position directly above this corner. Right, so I can have that out of there now. So my first hole is going to be 13 millimeters in from this edge, so I'm going to wind to 13 in X. Is there, and from my sketch it is 12.5 mil up, so I'm going to go to 12.5, which is there. And I'm going to lock X and lock Y, and at that point there is where I need a 15 millimeter hole. I have got a 15 millimeter reamer, so happy days. That's what's going to be used for that hole. So I think a series of drills, probably end up with something like 14.5, and then whack the 15 mil reamer through. So 10 mil spotting drill. A little fast. There we go. I think I'll probably whack a 10 mil drill through there now. Why not? I got the right collet. That's a 10mm spotting drill. I'm going to have to go up with my head a little. So while I'm grabbing the drill, let's just send that head up. That'll do. You know, things are falling on the floor today. That was my needle file. Let's come down again. Too far up. Okay, 10mm hole. Now my standard drills end at 13mm. I got a bit of a. I've got some 14mm. I've definitely got a 14mm drill. I think my Big Morse. I'm gonna have to come down a bit more. My Big Morse taper drill set starts at 14.5, but that's no good in the mill. So I wonder if I've got some Imperial drill at a dimension around sort of, I don't know, 14.5 to 14.8, something like that. I'll have to have a look. So the drill I'm after was a 9/16. This is a 1732, which will do for a starter. I haven't found a 9/16 yet. I'm sure I've got one. Little fast. A little bit of WD. I got a 5/8, which is too big. Definitely got a 14 drill. Oh, yuck. So that being, what was it, what did I say it was, 1732. Where are we now then? Let's have a look. We are at about 13.4, 13.45, something like that. So, I've got a 14 drill with a step down shank somewhere. No, that's a 16. What am I thinking? I will find the right drill, guys. So I dug deep into my toolboxes and I found a 14.2. And it's a little blunt. Just bring the head down. Okay, so yeah, I haven't got anything bigger. I'd rather have something like 14.6, 14.7, something like that for this 16mm reamer, 15mm reamer. But beggars can't be choosers. We're going to have to make the reamer work for a living. So 15mm reamer up and ready. Let's have a look. Yeah, that should do it. Nice bit of WD on there. We're getting there. Yeah. taking out a fair whack of material, this reamer. And the 14.2 drill is taking out 0.4 side. It's a brand new reamer, so it's pretty good. Well, not brand new, I've done probably 2 or 3 little jobs with it. Okay, so yeah, size isn't critical. The pin that's going to go in there, it's going to be nice running fit in whatever that hole size is, but you know, it may be a little under 15, maybe a little over. I'm not worried. Okay, so moving on to the next hole now. So distance across is going to be 67.5. So my X is set at, if I set X at 0, I need to come across 67.5. Went past it. 67.5 there. And the distance is only 10 mil from this space, so we're at 12.5 at the moment. Got to come back to 10. It's going to be the middle of the 20 mil. Okay, so that's 0, 0 there. So I'm 67.5 along, and I'm back 10.5 to 10, whereas that one was 12.5 from this edge. Okay, so let's send that head up, get the reamer out. This one's far simpler. It's going to be a 10 mil reamed hole, easy peasy. So I think we'll go back to 2 seconds, back to the 10 mil collet for a 10 mil spotting drill, which I put away. I'm going to put that reamer away now, in fact. Naughty, naughty. Clean the reamer. Back in its box. And just while I'm here, going to grab the 10 mil spotting drill again. Here we go. And back down with the head. So, you get the picture. I'm going to pop a 10 mil reamed hole in here. So the next step for this part is going to be, well, deburr these 2 holes when I take it out of the vise, is to put the rotary table up and do some rotary table shenanigans all the way around the outside. I'll probably do the major end first, or shall I do the minor end first? Who knows? But yeah, rotary table up. That's going to involve cleaning down the table big time and putting the rotary table up, getting it set up, all the rest of it. We shall do that, I believe, in another episode. That's probably going to be some rotary table shenanigans. Well, I think that's about it for this one, guys. A bit of bank holiday fun and games, a bit of stuff for work, something for myself. This part is going to be part of something for myself. I've been putting it off for long enough. I haven't had a chance to get back onto the Stuart Models engine for a while, but that'll be coming forward in the future, and we're going to finish this little project as well. There are probably 4 or 5 other parts to go along with this, but that will become clear as we go forward. Anyway, I think as we stand today, we're on about 9,600 and some odd, you know, maybe 10 subscribers. So, you know, we're getting very close to that 10,000 mark. So, yeah, we'll see what we're going to do as a celebratory if and when that comes. So anyway, guys, thanks to all the new subscribers for clicking that button. Thank you all for watching, and we'll see you all very soon. Cheers now.